Hello, welcome to my Grasshopper tutorial. Today I'd like to talk about creating if-then statements in Grasshopper as a way to split your parametric relationships based off of yet another parametric relationship. So what I mean by that is best demonstrated here in this script that we'll be creating from scratch. So what you see is a curve here that's drawn in Rhino. I have a curve at the bottom and a curve on the right, very simple lines. Everything else is generated in Grasshopper. And so what I mean by an if-then statement is creating these thickened triangles, but have them be related to proximity to the original curve. So if you see here, one of my outputs, all of these triangles that are within a certain distance of this curve have a gradient that's running from top to bottom, so we can see they're thickest at the top and thin at the bottom, whereas all of these triangles that are a certain distance away from that initial curve have a separate proximity or separate gradients based on their proximity to the curve on the right. So you can see they're thickest on the right and thinnest on the left. And so if we just take a look at that for a second, turn these off, and I'll just look at these as surfaces, so it'll be a little faster. I can show you exactly what I mean by having that. So the if-then statement happens here in the middle, and it's essentially based on a distance to that curve. So if I adjust this slider, it might take a second to regenerate. We can see I can control where that threshold breaks, which gradient is controlling, or which line is creating its parametric relationship, which line controls the thickness of the triangles. So here I've made it very small, so only the closest triangles are affected by the top-bottom gradients, and most of my triangles are running from the right-left. If I make this bigger, just to highlight, so you see, now you can see most of the triangles are being affected by the top-bottom gradients, and the remaining ones are the right-left gradients. So let's work through this from scratch to create this relationship. So I'll just go ahead and turn these off, and we'll start from the beginning. So like my previous tutorials, I'm going to build the initial surface from scratch by just making a box and grabbing a face from it. You could easily just import a surface as well using the parameters and surface and selecting a surface. But let's just build one so that it's all contained within Grasshopper. That way we can control its size, and the whole thing will remain parametric. So under surface, primitive, center box, we'll go in here. Let's make some sliders for this box to create the size. So I can go to parameters, input, number slider, or separately, which I like to do is just double click anywhere and just type slider. And we want a number slider. First thing I'm going to do is edit this slider because its default is set from 0 to 1, but I want it much bigger. And just to touch on what these numbers mean, these are going to be relative to your units that you have set in Rhino. So my units are in feet right now. So setting it to 1 means 1 foot, and 0.6 means a half a foot, and so on, or 0.5 means a half a foot. So I'm going to edit this, and I actually want to make it between 0 and 100 feet. And I don't want 3 decimal places, so I just want whole numbers. So I'll just take that to 0 digits, click OK, and I'll plug in my X. I'll control copy, control V to make unique ones for each, my X, Y, and Z of my box. I will make the X all the way up to 100, and I'll make the Y and Z at 20. So that will define the size of my box, 20 feet by 100 feet by 20 feet tall. So from there, I want to just extract this face here as my main face I'm going to start to be working on. So to extract that face out of my box, which has all 6 sides, I go to my sets, list item, and list item is going to want the items to be listed and the specific index that I want. So I'll put my box in here, sorry, got a step ahead. First, I need to explode this box. So if I go to Surface Analysis and go to Deconstruct BRep, I will deconstruct that. So now I have my faces, my edges, and my vertices of the BRep. And if I go to my sets, list item, now I can list through all of my faces and grab just the one that I want, which just so happens to be face number 0. The default index is set to 0. If I add another slider here, make it just whole numbers because I'm just dealing with faces, the max would be 5 because there's only 6 faces to choose from. Put it into my item here. You can see item 0, and then if I move through these, you can see each face will be selected in however Grasshopper defines that order. But it just so happens that I want face number 0. And so now what I want to do as I move through this, I'm going to keep turning the previous plugs off so that I'm only looking at what I'm doing most recently. It just keeps it a little cleaner. So I'll preview off and only deal with this face. So now what I'd like to do is to subdivide my face into a series of triangles. And to do this, I'm going to use the plugin called Lunchbox. If you don't have Lunchbox for Grasshopper, just Google Lunchbox for Grasshopper. It's a free plugin, and you just drag and drop it right into the Grasshopper window, and it should add it to your list of tools. It's a really great resource, especially for architecture. Its panelization of surfaces is amazing, and offsetting panels is also great as well. There's some really great structures and grids you can make here. Definitely a must-have. So for this, I'm going to use the Triangular Panels A. This is just a fun breakdown into small triangles that I like to use a lot. So it's looking for a surface, and it wants then the U and V breakdown. So the surface is, of course, my main surface. I'll put that in here. You can already see what it looks like is the default. So what I'll do is I'll make a few more sliders. Actually, I will just copy some of these old ones, use them again as my U and my V. So I can start to play with the breakdown of scale of these triangles as tiny as I want. Be careful not to make them too big so I don't crash my computer. For this, I'm going to set my U to 30 and my V to 15. Just for a nice clean scale. It'll be big enough to see what we're doing, but not too big where it's too much data. So here is where I'd like to create the sort of if-then statement. And what I mean by if-then statement is I want to make a definition, a defining point that'll split my data into 2 separate paths that I can do unique things with. But I want the threshold for that to be editable to keep this entire thing parametric. So my if-then statement would read as if the center of a triangle is within a certain amount of feet of this curve, then go to list A. If it is not within that distance, go to list B. So to do that from a Grasshopper standpoint, and it's very common in scripting to just to write that into a script. But from a Grasshopper standpoint, the method I like to use is going to math script evaluate. And so evaluate wants you to does exactly what it says. It's going to evaluate an expression. But from an expression standpoint, I'm going to keep this really, really simple. So my evaluation plug has nothing in it yet. I'm going to right click it. The expression to evaluate I'm going to right click. So that's the F input. I'm going to right click and go to expression editor. And so this is where I can kind of type in my script of what the evaluation is. And to keep it the simplest way to do that, seeing my variables are X and Y, which you can see here I have an X and Y input, so that's what's going to be. I'm simply going to type in X is greater than Y. Click OK. And of course it gives me an error right now because there's no input, so it doesn't have anything to figure out if that makes sense or not. So what is the data that we're going to use to decide if X is greater than Y? What's X and what's Y? So X is going to be the distance to the curve, and Y is going to be the threshold that I create to decide if the data goes to list A or list B. So to get the distance from each triangle to the curve, what we'll use is a curve closest point. So if you go to curve analysis and go to curve closest point, that's going to want the curve to project onto, and it's going to want the points to project. So the curve is going to be simple. It's going to be our curve in Rhino. So to bring that into Grasshopper, we'll go to parameters, geometry, and go to curve. Right click on that, set one curve. We'll select it in Rhino. Now that's gray. You can see it turns green when I select it. So now that is in Grasshopper. That will be my curve. But for the points, all I have here are panels, right? I have these surfaces. I don't have points. So what I'd like to get is the center point of each one of these triangles. And so the easiest way to do that is to just go to surface analysis and go to area. Area is great because if I plug this in, it's looking for surfaces to add to it. So I add that in. It gives me all the area data. So these triangles are all 8.88 feet or square feet, which I don't really care about. But it also gives you a center point, which is what I actually like. That's the more interesting thing for me. So now I could take that center point. I have a center point for every single one of these triangles and plug that into there. So now I have a distance between every center point to its closest point on this curve. And when I get the results, you can see I get all these points, which are showing up here, which I also don't care about. But I do care about the D output. That is our distance between the base point and the curve. So those are all my distances from each one of these points down to here. Every one of these is drawing a tangent line to find its closest point to this curve. Turn that off, turn this off. So I'm going to use those distances as my X value. And now my Y value, I'm going to set as a slider. So I will just copy one of these from over here, Control C, Control V, plug it into Y. So now it turns gray because I have an X and a Y, and it now is trying to compare if the distances are less than 30 or greater than 30. So let's just take a quick look at the data to see what a good threshold might be for this. So if I just type panel, we get this blank yellow panel. This is just a way to look at the data within these plugs. If I plug in my distances, I can see these are all those distances. So every single one of those points in of all these triangles has a distance, and that whole list is right here. So these are all the points. And so you can see we have quite a wide range. And so those are my X value, and these are my Y. So remember, my expression is X is greater than Y. And my result is if X is greater than Y, it's going to be true. If X is not greater than Y, then it's false. So each one of these distances is going to give a true or false outcome. And so what we can do is use that true or false to divide our list, creating a sort of if-then scenario. So to do that, we'll go to Sets and Sequence, set to list and go to dispatch. So dispatch is going to split our data into two lists. So it wants the empty list of data to split. So the list of data is just our original panels. And then it wants the pattern, right? So its default is just true and false. So it'd sort of just be a B, A, B, A, B if you let that run. But we have a different pattern here that is based, it's a true false based on if a distance is greater than 30 in this case. So we plug that in. Now what we have are two split paths here. And so when you click on dispatch, what it's going to do is it's going to select every one. So it doesn't really look like anything happened. But you can see if I hover over A, I have 19 items here. If I hover over B, I have 881 items here. So there is a separation. So what I'd like to do here is just go to parameters and go to surface and just make a couple surface plugs here just so that I can select them individually and see what's happening. I'm going to turn all of this original stuff off because it's going to get in my way. And now when I click here, I can start to see what I have, right? So this doesn't quite make sense. I think my threshold's too big because the only pieces not in that threshold are these little triangles over here. So let's turn this down. You can see once I get down to like 8 or 9, now my threshold is, 5 feet away from the curve or 10 feet away from the curve. It starts to make more sense as an even distribution. So I can see this list up here is all of my triangles that X is greater than 10 go here. Everything where X, the distance, is less than 10, which would make it false, go here. So now I've essentially split my data into two new paths, which is great because now I can make definitions for each path, but also knowing that I can change this threshold here to keep this script completely parametric. So let's just do a very simple proximity gradient to express that'll express differently in each data set. So for the top one, I'd like to do a gradient of thickness from right to left. So this curve will essentially be what controls that. And then for the bottom one, we'll do a gradient from top to bottom. It's just a simple way to express the differences in the patterns. So to do a gradient of thickness for these triangles, first thing I'm going to need to do is to create a relationship, a proximity relationship to this curve here. So this is just a curve drawn in Rhino. So what I'll do is I'll import that curve into Grasshopper. So curve, set one curve. I was already selected, so now it's in there. It's great. So what I'd like to do is find the distance between each one of these surfaces and that curve. So to do that, I'm going to, again, use my surface area. That'll just give me an easy point to judge from, which would be the center point of each curve. And then I'm going to, again, use my curve closest point. So my curve is the straight line representing the far right of the project, and then my points are my center points. So now I have all these distances, and so what I'd like to do is have that distance translate into a way to define the thickness of a frame made out of this surface. So to make a frame from the surface, we'll again go to Lunchbox, and we'll go to a panel frame. So a panel frame is going to do exactly that. If I just take my surfaces and plug it in originally, we can see what that generates. So all these surfaces, turn this off. Right. So all of these surfaces now created little frames, right? So my output is the frame and the panel. If I just add some little surface parameters, so I can look at those individually and turn the entire thing off, I can see just the frame, just the frames, and just the panels, the middle panels. So I'm going to turn this off because all I want is this frame. So now all I've done is made a frame for my surfaces that are greater than a certain distance from our initial curve. So those surfaces, right now, the thickness of that frame is being set here, and it's a scale factor between 0 and 1. So it's set to 0.5. So basically, the thickness of this is half of the thickness of the entire square or triangle. So what I want to do is create that relationship of thickness based on the distance to this curve. So I have the distances from each one of these to this curve, but I don't have it in a scale that makes sense that what it's asking for. So my scale factor is from 0 to 1, and all I have are these distances that are 201, 199, 201. So what I need to do is convert that data into a domain that makes sense from 0 to 1. So to do that, what I'd like to do is go to Math and Domain. And there's three things that I always grab here when I'm going to remap a domain. I need a construct domain. I need the bounds. And I need the remap numbers. So these are this trio that sort of works together to do this job. So remap numbers, it wants if I just hover over here, it wants the values to remap, the source domain, and the target domain. So let's start with the values to remap. Of course, that's going to be all of our distances, so we'll plug that in there. So what's the source domain? Basically, what's the biggest and smallest number that's in the original list of numbers? So if I make a panel here and plug these in, you can see this is my huge list of numbers, right? So what's the biggest and smallest number in here? Well, I don't want to go through here and figure out what's the biggest and smallest number. So bounds will do that for me. So if I plug this into bounds and plug this into here, it just tells you the smallest number is 5.7, the biggest number is 201. Perfect. So now we know what our original is. So now what's our target? Let's make a slider here. So if we edit this, we know the default is from 0 to 1, which is exactly what we want. So I'll make a Control V, put in for A and B. The domain start is going to be 0, and the domain end is going to be 1. I'm going to pull it in just a hair on both ends because I don't want my panel to be completely closed. So I want it to be, 97%. So now I've created a new domain that's from 0 to 1. So that's going to be my target domain because remember, my scale factor is going to be between 0 and 1. So now my remap numbers, if I plug this into a panel, we can see all those distances have been converted into a number between 0 and 1 relative to how close they were to between 5.7 and 201. So all of these numbers are under 0 now, which is perfect. So I will remap those into my scale factors. This might take a second. So now, kind of clean this up a bit. So always try and keep these clean so you can see what you're doing and what's plugging into what. Can hide that for now. So now, if we look at what's happening, we can see these panels are super thick, right? There's just a tiny little hole there. So if I adjust that, sorry, wrong side. If I adjust this, I can control the smallest hole, or a different way to think of it is the greatest thickness of the triangle. And then on the other side, farthest away, are these much thinner pieces. So if I pull this in, these can kind of thicken up a little bit. So now when we look at it as a whole, we can see it's a clear gradient of thickness from right to left of all of my triangles that don't meet the Ifthen criteria initially set forth in here. So let's do the same thing for the other triangles, which are these guys, which we kind of left over here. I can essentially copy and paste all this little mini script I made right here. So let's take this, Control C, Control V, put it down, but instead we will use our other surfaces, so that will plug into here, and it'll plug into here. So the problem with this is now we are having this curve still based on this one over here. So what I want to do is go to this curve and now use the bottom curve. So I will take this and go to set one curve, select it in Rhino. Now we can see turn that off so it's a little more clear. All right, so now we can see that these curves have their own gradient where they're thickest at the bottom and thinnest at the top. But let's say I want it to be thicker at the top and thin at the bottom. I can simply just flip these, right? So maybe this is 0.85 and this is 0.15. Now we have the thickest at the top and the thinnest at the bottom. So let's take a step back and see how this plays out, right? So we have our triangular panels throughout our entire facade or surface for now. We'll just call it an abstract surface, except for that everything that is greater than 10 feet away from this curve now is being controlled by a thickness gradient from right to left, but everything that's within 10 feet is being controlled by a thickness gradient from top to bottom. What's great about this now is that I can still control that threshold. So let's say that I wanted that threshold to be smaller and only be 5 feet. Now these very few triangles are being controlled where the majority of them is seeing that right-left gradient. And now, so just to make this a little bit more consistent and a little bit better to look at, I'm going to change my max and min to 0.25 and 0.85. And I'm going to just give these panels a little bit of thickness before I bake them in Rhino. So to do that, we'll just simply go to Surface and Freeform Extrude. And so Extrude wants the surface to extrude. We'll give it all of our surfaces. And then it's also going to want an extrusion direction. So it's looking for a vector, which is a distance in a direction. So we can just create a slider to tell it the distance. So I'm just going to type in, let's say 0.5, which is half a foot or 6 inches. And that won't be enough to just input that there. I need to tell it which direction I want to go half a foot. So if I go to vector and go to the Y direction, because if I look in plan here, I can see here's my object, here's the Y direction. So I want to extrude along that direction. So now once I plug this in here, now I have Y direction at 0.5, put that into my extrusion. let it do some thinking. There we go. Now I have some thickened triangle panels, and I will copy paste and apply that to these surfaces as well. So now all my pieces are thickened. I'm going to set my threshold to 10 feet because I thought that was sort of the cleanest way to see it. And now I would simply bake my two data sets onto different layers so I can start to understand how it looks actually in Rhino. So I'll just go to layer 4 here, select these extrusions, right click, bake, turn them off. And then I'll go to layer 5, select these extrusions, right click, bake, turn it off in Grasshopper, and minimize. And so now I can see my actual surface, my actual thickened triangle pieces here in Rhino. I can start to see where that threshold is created based on this curve. And visually, I can start to understand there's a top-down gradient and a right-left gradient sort of blended together based off of this initial curve. So the other thing that makes this very useful is that not only can we always go back in and change all these parameters, turn this off for a second, turn these back on. Well, I'm going to turn these surfaces on. This will just be a little bit faster. I don't want to crash my computer at the moment. So all of this, because they're based on this curve, not only can we change these parameters in here, if we wanted to adjust the curve in Rhino, we can come back in and change our curve, and it will adjust the entire script still based on the proximity of the new curve. So now what we can do is come back in here, maybe make a layer 6 and a layer 7, and bake those again on separate layers. I'll just use that for comparison. And now we can very quickly jump between ideas to see which one we're liking more. So that was the original. That was the original. That was the second attempt. There we go. So I moved the curve and created this new option. If I go here, you can see the original. All right, so we will leave it with that. Thank you.